Dear colleagues, good day. It is my pleasure to be one of the participants in the 24 hours concrete knowledge organized by the ACI for this year 2024. Because of the tight time, we'll go quickly to our presentation. The subject title for my presentation is Tips on Shotcrete. Quickly going through the topics that I will explain in my presentation. First, I'll give a brief introduction on Shotcrete. Second, the advantages and disadvantages of Shotcrete. Third, Shotcrete applications. Fourth, Shotcrete processes. And 5, materials, proportioning, properties, and preparations. And finally, Shotcrete equipments. A brief introduction on Shotcrete. First, Shotcrete, to define Shotcrete, which is also known gunite or sprayed concrete, and as per the ACI terminology, is concrete applied through a high velocity pneumatic projection from a nozzle onto a surface. That means a receiving surface. The Shotcrete is widely used since 1910, which is were the basic idea for shotcreting. For many decades, no specific provisions was presented in ACI 318. Just in the latest ACI edition of 2019, there is recent provisions included in the code, which is distributed on the chapters 19, 25, and 26. Over decades, enhancement in equipment and admixtures and robotic placement were developed, and also in the materials, which increased the Shotcrete's effectiveness and expanded its applications. Now going to the advantages and disadvantages of Shotcrete. The advantages: first, it is cost effective. The Shotcrete process reduces or eliminates the need for formwork, resulting in about 50 to 100% savings in cost. Also, the Shotcrete process is ideal for areas which are hard to reach. Also, the Shotcrete gives flexibility, that is, it is suitable for thin layers of concrete, variable thicknesses, and for the complex shapes that cannot be done using the conventional concrete casting. Also, for the equipments used in shotcreting, only requires small space, and they are a small portable plants for placing the shotcrete. Also, the speed in shotcrete process is also an advantage, which saves about 33 to 50% in stoppages and interruptibility during the works. Also, the shotcreting process provide excellent bonding properties and durability with existing substrata for the whole shotcreting work. Also, one of the advantages of the shotcrete is it is effective for overhead and underground applications in restricted areas and hard to access. Now, coming to the disadvantages of the shotcrete, it is rather a complex procedure because it requires highly skilled labor, especially for the dry mix process, which we'll explain later. Also, there is a higher wastage in shotcrete process compared to conventional concrete casting because the rebound amounts of concrete wasted, especially for the vertical and the overhead surfaces shotcreted. Another disadvantage is the time consumption for the process, which take rather higher time to finish the shotcrete. You know, when we use a shotcrete process, the last surface, if we have a multi-surface thickness, it needs to be finished. So that is taking time compared to conventional concrete used with formworks. Also, the initial cost for the shotcrete is higher compared to conventional concrete, but shotcreting is economical over the life cycle time. Now we come to the third topic of our presentation, the applications for the shotcrete. First, it is used in repair and restoration of structures, and that it is used for repairing deteriorated concrete beams, caps, columns, abutments, underdecks of bridges, and also for restoration of steel or wood structures. As we see here in figure 1 for this arch bridge, which is completely repaired using shotcrete. Also here we have these in figure 2, we have 2 photos for repairing underdeck and piers of concrete bridges. And here also in figure 3, while repairing the viaduct bridge, and it is piers. The third application is for the ground support. The shotcrete process is used to stabilize earth and rock excavation and support mining and tunneling operations underground. As you see here in figure 4, where shotcrete is used for constructing backfill barricades, which reduce manpower also and the cycle time, saving cycle time. Now another application for the shotcrete is in new construction, especially to construct tunnels and also used for slope stabilizations. The advantages comes here to reduce construction costs by, of course, minimizing formwork, and it is also useful for using in straight, curved, and irregular surfaces and shapes. That is hard to implement in using the conventional concrete. Another application is in constructing pools and skate parks, especially with complex shapes. It is economical for such use and watertight, durable, and architecturally nice looking structures, as we see here for this swimming pool constructed using shotcrete. Another application is for constructing tanks and dams, as you see here in figure 6 and 7. The shotcrete here produces a watertight and durable tanks for various liquids and also for dams. Tanks also used for storage of chilled water, industrial wastes, wastewater, and the shotcrete process can be used for constructing dams up to 60 meters in diameter. Another application is for constructing complex architectural structures, landscapes, and zooscapes, as you see here in figure 8. That is hard to construct using the conventional concrete casting. And another application is in refractory for repairing and placing new linings in industrial firing and melting facilities like blast furnaces and cement production plants, which are subjected to high temperature. As you see here in figure 9, this worker is shotcreting and repairing the lining for a brick factory. Now we come to the fourth topic in our presentations, the shotcrete processes. We have two main types of shotcrete processes. First, the dry mix process, which we here brief it, and it is steps. First, all ingredients are mixed and only pre-damped just to 6% of moisture. Then it is feeded into a delivery equipment and then metered into a delivery hose. Then water is added at the nozzle just prior to projecting and jetting the mix onto the receiving surface. The second, as you see here, this is a schematic diagram for the process. As you see here, pre-bag shotcrete and shotcrete gun, air compressor, and water supply, and the water just added at the nozzle, and then it is jetted on the receiving surface. The second main type of shotcrete process is the wet mix process, which is the first step is the mix all ingredients, including water. It is different from the dry mix. Here we add water directly with the other ingredients. Then the mixture is poured into a delivery equipment and metered into a delivery hose. Then the compressed air is injected at the nozzle. Then the mixture is projected on the receiving surface. And also we have a schematic diagram for the process, as you see here. This is the ready mix concrete from the truck mixer, then the concrete pump, the air compressor, and all the concrete here is pre-mixed, and then it is pushed by the air pressure and then jetted on the receiving surface. Now the fifth topic is the materials proportioning and properties of and preparation of the shotcrete. The materials used in shotcrete, of course, includes the cement with its type 1, 2, or other types as per the required properties, and the supplementary cementitious material SCMs like fly ash, silica fume, and others. Then the aggregate, maybe it is normal weight or lightweight aggregate as per the usage and the required properties for the work. Then the mixing water, which is a potable water. Then admixtures with the main 5 types: accelerators, air entrainment, water reducers, retarders, and rheology modifiers. And the other material is the reinforcement, which may be reinforcing bars, welded wire reinforcement, or fiber reinforcement. Also, we may need curing compounds for the last shotcreted layer if we have a multi-layer thickness for the member to be constructed. Also, we may use some bonding compounds if we have some delay in time when placing of subsequent shotcrete layers to bond the successive concrete layer. Then we come to the mixture proportions. For dry mix, the proportions is based on the cement aggregate ratio. Water is added at nozzle based on the evaluation and experience of the nozzleman to evaluate its consistency prior to jetting it on the receiving surface. In the wet mix, it is similar to conventional concrete mix design, but of course with some adjustments to simplify the pumping and for the durability requirements of the resulted concrete mix. Coming to the surface preparation, sometimes the receiving surface need to be air water blast, or maybe dry sand blasting, or wet sand blasting, or grinding, and sometimes high pressure water jetting. This is prior to jetting the mixture on it. The preferred substrate condition for the receiving surface for the shotcrete is the SSD, which is a saturated surface dry condition before the application of the shotcrete. Coming to the properties of the shotcrete, we have the compressive strength, which depends on the cementitious material to aggregate ratio and water cement ratio. Flexural properties using reinforcement bars, welded wire, fabric or fibers, and it is similar to cast in place concrete properties. Durability depends on the water cement ratio and the cementitious materials content, and also for the air and on the air void system quality. Bond strength may be gained using hydromilling, sand blasting, chipping followed by sand blasting. For the shrinkage, it is highly potential expected because of the small aggregate size, and when we use lower water cement ratio, it reduces shrinkage, of course, as we may know. For the slump, it is typical for the wet mix shotcrete to be in the range of 50 to 100 millimeters, but when we are using admixtures like water reducing agents, this will not be applicable, of course. Now coming to the sixth topic, the equipments used in the shotcreting. We have, as we know, two main types of shotcrete processes. For the dry mix equipment, there are two main types: pressure vessels, which are batch, and rotary or continuous feed guns. And we won't go in depth for the details of this topic, but only showing this pictures for the samples, two samples of the dry mix equipments, as you see here. For the wet mix equipment, which is preferred for higher production rates and improved by advancement in wet mix pump technology, as you see here in this one, this unit used for wet mix shotcrete, and here also this is a compressor, air compressor here with the equipment, the other equipment mixing the concrete, and this last one for truck mixer with air compressor used for wet mix process. Lastly, development and future research may be in the field of structural design, nozzle design, in-place testing techniques, materials, equipment, mechanization, substrate evaluation, process automation, surface finish, and reinforcement encasement. Thank you for listening, and see you in another scientific occasion.